Hey everybody, this is Larry, Biweekly Contest 18. That's pretty much it. uh, yeah, hit the like button, hit the subscribe button, hit all the buttons. As usual, there'll be links in the description and so forth, so feel free to click to skip ahead and so forth. Yeah, that's pretty much it. Leave a comment below, let me know what you think. Wish me luck, starting in 2 seconds. Let's go. Cool. Let's start that problem. I saw the 10 pointer. I was already intimidated. But yeah, rank transform of an array. I probably could have done this faster. But I think I was not warmed up when I was doing this one. But in any case, I think as soon as I open this problem, and there's a link below, I think the first thing I was trying to do was trying to maybe have, I was wrapping around an idea of like sorting it and then resorting it and then, yeah, sorting it and then resorting it another way. But I did not do that. So yeah, so I couldn't figure out quite how to do that. So I was like, wait, I could just I could just, use a helper array. Like we don't have to do this the hard way. So that's pretty much it. That's essentially how I end up doing it. But that's what was thinking for the first minute. I was like, how do I do this in a clever way? And it turns out I didn't have to. So yeah, I was trying to be too clever. I should have just copied it away, and then I don't know. I think still right now I was trying to be a little bit cute about how to kind of go about it. Yeah, after that I was like, okay, let's just, and then convert it to a lookup. And then after that, we could just map it back. And that's essentially what I did. Oh yeah, I forgot to sort the original array, obviously. And then after I did that, I was like, okay, this is easy. This is good. And then second, put a palindrome. I was trying, I think initially I was trying to figure out a way to figure out like how to, like if there's a greedy algorithm or something like that. I was like, oh, okay. I mean, and it turns out that there is, but at the time I didn't really know that. I was like, okay. What can I get away with? I was like, okay, if I do greedy, maybe I move from the front to the back, change it to an A, and then check or something like that. But yeah, I worry a lot about the edge cases, and I didn't really, well, I just didn't really want to think about the edge cases. So I tried to do something that was a little bit, and definitely not a. Let me try to, well, yeah, try to do brute force. I mean, so at this point, I knew what I wanted to do, which is that given the n is equal to 1,000, I wanted to try changing it to every character and then try again. But and then check that it is not a palindrome. But I was worrying a little bit about performance in Python. Even though I guess some of these things are C optimized, because in the worst case it's like maybe n square or something like that. Even though I guess in theory it's hard, because for each of the characters it does a string comparison, which is all n times 26. And also like the slices and off by ones. I didn't really want to think about it. So I guess this is about a minute and a half in. I changed to C++, mostly because I know how to do in-place character replacement really quick. So I was like, okay, let's just do it that way, and then kind of see what happens. Brute force, and yeah, at least for me, it passed the examples though, or the system testing. Maybe the testing is a little weak, but 26 million is probably should be on the okay side, and that's the worst case, which maybe is very hard to test. Because most of the time these are not palindromes, so then it would probably terminate early or something like that. The one optimization I could have done is that if we try for a character, we probably could just return early. Like we didn't need to keep going. As soon as we find one, we could just return. Right? No, that's not true. Now if they're all prefixes A. But I guess this is so yeah. At least for so see, make another mistake right here, just me talking about it afterwards. But that's why I was trying to do brute force as much as possible, knowing that it is relatively within the constraints. But yeah. I don't know why it doesn't do the intent for me, but oh yeah, and I have to write this palindrome function pretty much. I actually did this pretty quick considering that I wasted 2 minutes of thinking about it in Python. I mean, I ended up doing this in 5 minutes, so. Yeah, and the beauty about brute force is that, yeah, I got the sign wrong. That's why we test. But the beauty of brute force is that once it passed the example test, I was like, okay, well, I mean, I literally try everything, so I'm more confident about it, except for maybe running time. So when it was accepted, I felt great. Okay, sort the matrix diagonally. It is what it kind of sounds like. I think this is one of those problems that you could take a long time, but essentially it's just implementation. I think I was working on I think the other day. I guess maybe the other day was like a couple of weeks ago now. But I remember working on an n queens problem, and in n queens you deal with diagonals. So I think from that is how I was able to kind of already know what I wanted to do, especially in Python. Yeah, I mean, you kind of see where I'm going with it. I was trying to figure out how to kind of go through the array. I've been trying to pick up, though I was sometimes not always successful, of naming them rows and columns instead of N's and M's so that I don't confuse myself. Because these are much more, yeah. Hopefully it sticks. But yeah, but I was like, okay, so given that this element, what do we want to do with it? Well, the diagonal is just that. Thought it could also be here. Yeah. And that's pretty much it. I think from that, I was like, okay, I know well, the second half of the problem is like, well, okay, I know how to get, well, you need to sort each of the diagonal, which is easy. And, I mean, still seems like I spent a good amount of time. Well, and by that I mean just like probably on the order of like 20, 30 seconds. I just want to confirm to myself that like, I don't know. I think I was trying to be too cute, to be honest. And when you see what I tried to do, like I was just like, I don't need to be that. Like I was trying to do something funny, but now you have the keys. Just do the keys. Terrible naming though. Now that I see it, but I think it's fine for a one-liner. And then now, I think now this is the second half of the problem, which I'm trying to figure out. Like, okay, how to kind of put it back in a good way. And I thought maybe like there's something like formatic about it, but I think I spent a couple of minutes playing around with this. Maybe it's worth me actually, what do we call it? Maybe there is a mathematical formula that I could be a little bit better on with a mapping. But I end up just noticing that the way that we visit it, we're always going to visit the ones in the upper left corner first. So, and that is the order that you want anyway. So, so I was able to kind of, I think I took a little bit of an unnecessary risk. I could have just converted it to a deck and then just pop it, because in Python, I don't know. I actually don't. In theory, in Python, this list operation is O of n. But that said, you can only do on the order of like n choose 2 or something like that. So O of n square, but for n in this case is 100, so it's not that bad. But you could get it down to still a little bit more. Well, in this case, it is each of those things are over 100, so n squared. So anyway, it is not great. So I'm sure that Python has some optimization, but because I just end up like taking the first element and then I think I could have just also kept a variable for checking. Don't know why I didn't do that actually. Now that I think about it, because then I'll make it all one. But it was all just like in the moment. I just really wanted to get it out, so I did this array slice thing. Then it looks okay. I was double guessing like, is it worth fixing this? I was like, okay. To be honest, wasn't sure on this one. Due to the timing, maybe slow. Okay, the hard problem. We will sub array to maximize array value. Yeah, I mean, I think in retrospect, I should have took a nap because I'm still very tired. But yeah, I mean, there's gonna be a link below to skip ahead. I think I end up talking about how I thought up throughout this problem. But this is gonna be a long. I don't know. Maybe I'll fast forward this part because I don't think there's anything. Like I'll fast forward and post edit because I was just doing a lot of stuff on paper, just trying to figure it out. I landed on a couple of things that I should have proceeded on, but I was too tired to grind it out today. Maybe I really should have grinded out a little bit. It was probably doable, but a little bit tricky. But yeah, yeah. I mean, I'm going to for this, but you can also click on the link to kind of skip ahead. But yeah, that's all I have for this contest. I only subbed 3 problems today, but still finished in the top 100, so I don't know what that means. Anyway, have a good night. Well, um, was really stuck on this one. I mean, I think I had some ideas about greedy in some ways, and dynamic programming come from those greedy album, but I couldn't quite put my code. Can't put my hand on the code. I think we do. I don't know. I guess we'll kind of watch the code, watch the what you call together. The what read other people's code together, but I think there's some stuff about like well, this is a constant, this is a constant. So I think because on this part, there are only 4 possibilities, which is that this is going down or going up, and this is going up, and this is going down, and then in some way, kind of merge those together in either a search or something like that, and that should give me like a DP of like dynamic programming of like 4 times n states or something like that, and then maybe we can build something off that. But I was trying to. I think I spent too much time trying to think of something that's a little bit more clever. Just automate it and get it. Yeah, well, let's see where I am at in my ranking, and then maybe I'll fix it later. Well done, people who are on top. 97, but I guess not so bad considering I didn't do well. But 60th maybe, or 97. I don't know. Either way, kind of kind of wow. Had a lot of time to do it too, because a lot of people took a lot of time. But ultimately, just didn't get it done. Yeah, I mean, I guess I should have just, maybe that's what I should have done. I should have just follow it through. I think I was just trying to figure out an easier solution, but maybe I underestimated the problem. Cool. Let's kind of go over the problems. Well, I mean, okay, let's go over the problems that I do know, and then we'll do code reviews together. Um, cool. The first one, yeah, I mean, I think that was straightforward. I ended up taking 3 minutes, but that was probably slower than I needed to be honest. I think I had just some, I don't know. I think I was trying to be too cute in that I didn't want to mutate the original array, and we don't have to, but ultimately by making another copy. But I was trying to do something fancy with maybe like I was sorted and then re-sort it back or something like that. So I was stuck in my mind for a little bit for that. So that's why it took me a little bit longer than I guess other ones. But yeah, so that was the first one. Second one, I mean, second one was just a brute force. I ended up switching to C++. It still only took me about 5 minutes. Would have been faster, but I think it was, I just, I didn't want to risk playing around with indices in Python and like strings, and I knew how to, in C++, you could just do it in place really easily. And what I did was that I was trying to think about whether there was like some strategy to kind of do it in a very uh, um, like some greedy way to get the minimal answer. But instead, I was like, okay, there's only 1,000, and there's only 1,000, and there's only 26 characters, so let's just try all of them and then get the smallest one. Technically, that is the worst case is going to be something like uh, yeah, like n squared times 26, but a lot of them. A lot of them are, I don't know, maybe the test cases are weak, but 26 million should be okay, especially if you're doing C++. So that's kind of my thing. It tells me how much time I. But yeah, Pi I wasn't worried about performance for an n square e thing. Um, yeah, sort the matrix diagonally. I probably could have done be slightly more efficient, but I didn't need to be, which was thankfully I held my breath for this one. But essentially, I just put all the numbers in a diagonal. I sort them, um, and then I kind of pop them one by one. I and this is technically O of n, so that's why I was a little bit worried. I should have changed it to a deck so that it would be more efficient. But maybe there's some under the hood things that makes it fast enough. And also, I guess technically, you only have uh, like your biggest diagonal is always going to be at most 100. So maybe that's why it's okay. Because you get some like 100 choose two thing, which is only like, you know, 10,000 or something like that, right? Or 5,000 or whatever. So, but yeah, but that was kind of my code here. Here, I think it's some dynamic program thing, but now let's, since I didn't solve it, uh, let's let's take a look at how other ridiculous these smart people do it then. Hmm, cool. Where's my final rank? I feel like I've been at the same rank, but then they didn't update to, I mean, 68. 68's, given a easier hard, I might have, I don't know, can't complain about 68 with only 3 problems solved. So, yeah, let's see. Okay, so this is, yeah, I mean, I guess this is kind of what I was saying, except for, wow, this is beautiful. All right, let's see. don't know why this works. Oops. Oh, wait, okay. That's just because I didn't realize it did the sum here. But, okay. What is going on here? I mean, this is beautiful and also took 2 submits, but that's kind of cool. I mean, I thought it would be something like similar to the other one, but this one is done. I mean, I guess this is sort of a greedy, but I have no idea how that works. Or like, I mean, like this part, I don't know how a lot of this part works. Because, well, okay, so these 2 for loops are just, I was about to write something similar, but essentially that's just if you swap a number to the front, and then and also the opposite, would just swap the number to the end. So that okay. So I do understand this part, because I was about to write something similar, but this part is the fun and tricky part with that I don't quite understand. Basically, for the left, or I mean, presumably that's why you used to have you get the min of all the prefix mins, and then I mean, I guess it's greedy in some way, but I just don't understand it necessarily. Hmm. Like I mean, obviously I know what the code is doing, but I'm trying to work out an algorithm from why that is the case. Um, yeah, you don't even use it anywhere else. Why is that the case? Some numbers. Hmm. Well, let's look at another one. Maybe I get a little bit more hint. That was so compact that is C sharp. See, turns out you can't. What was that? I forget quite quick time. I was just gonna say that, like, look, in C sharp you could. I thought it was going to be more dynamic programming, but it seems like there's it's sort of a greedy, but I don't know if I understand that sort of greedy. Well, I guess the lesson here is that don't give up and keep on just trying things. In my sense, I mean, I'm not suggesting that's what people did, but I guess I had the same ideas of some sort, but wasn't able to convince myself that that was good enough. Because I had some, I mean, I thought this was some sort of, I mean, I had some idea that was similar in terms of greedy, but I just couldn't really wrap my mind around the different cases. Um, but I don't know. I don't know that maybe I what is this Hoji thing? Is that like a maybe it means something in Japanese or something? Because a couple of people have done it, and they both have a Japanese flag or JP. I don't know if that's true. Maybe it's just a conjecture. Okay, maybe I can. Yeah, so this that part I knew. Delta's yeah, okay. So I had that. Okay, maybe that's a base case. Mr. C, why D? Hmm. D is equal to I think I have to figure a better way to visualize this. Um, I mean, I guess this is just dynamic programming in some way. Yeah. I mean, yeah, essentially, I guess this is the dynamic programming solution with the possibilities on the thing, but I really have to. Oh, I get it, I guess, a little bit. Well, I mean, it was. I get it. Okay. I mean, it was something I was thinking about how to make that transition. This is a very clever way of implementing kind of the code that I had in my head a little bit. In that this row and the row two are kind of mirrored, as you can see. So then from those two things, you can. So that's like the transition to kind of get at the last. Well, this is like the suffix prefix thing, um, and the best s it will hold the of all the stuff that you've already seen. What happens if you remove it? And then here is processing an incoming one. So so it's kind of like a sort of like getting the similar to what I guess we've seen before, but this way it's more kind of in tune with what my understanding was that it gets the max of all these values in the previous. Well, I don't know if I could have done this during the contest quite like this, but this is pretty. This is pretty, and this is just the current index, and this is like the best of all the index we've seen, but the inverse of it. And the mapping is such a way that they're kind of refractive or something. I don't know what the right vocabulary is. Okay, that's kind of cool. Hmm. I guess I was. I mean, my code is. I guess I think one thing that I mean, maybe is an excuse that I didn't sleep that much in the morning, but this is actually. I mean, this does the same thing as what the last solution that we took a look at, but in a way that is very intuitive. Uh, because this is just like the. If you think about this, this is n square, and this is actually the code that I've been staring at for way too long. I was trying to write. Maybe not. Well, but I didn't have. I mean, this is like. I think if you looked at, like, if you write it naively and then square, and then you kind of look at the function and you're trying to maximize things, a j such that those numbers are true. Yeah, I mean, I think it's just like one layer of abstraction that, or not abstraction, but like of like in a derivative, I guess, which is kind of true for this problem, but one level of difference that I was struggling to kind of visualize in my head. Okay, cool. I mean, yeah, overall a pretty fun contest, which I did a little bit better. But and I think this is related to the other, oops, the other one that we saw. Still don't understand quite how taking the min and the max of a JSON thing. Maybe I have to really think about it. But cool. Yeah, overall a fun contest. This is tough, but all right, cool. I'll probably do the one tonight. So I was, hopefully you'll tune in then. Not bad. I mean, still, not. Ooh, I guess they added in more servers. 91st. 3,000. Just not bad, I guess. For if I'm like 6 of all the pure crew finished only 3 problems, but cool. Probably should have. I mean, it's a little bit of a stretch, but I feel like I probably should have tried a little bit harder and maybe gotten the number 4th one. I mean, even this person had like 15 submits, but he did not stop trying. Okay, well, I was going to say something like, at least he kept on trying, which is technically true. So, but but yeah, I mean, these people, like, they have 10 submits, but they keep on trying and they keep on, try to figure out how to do it. So more power to. Well, okay. There's definitely some like very dubious cheating going on, but hope they catch those. This looks like a. I was gonna say this looks like a legit one, but then, well, I did it offline. In any case, So maybe my rank will go up a little bit after they remove the cheaters. But cool. See you later. I'm a little bit tired.